fighter that climbs past the clouds, out of the atmosphere, and strikes from the edge of space, then returns to base like nothing happened. Not a rocket, not a bomber, a sub-orbital combat jet, the next leap in air power. Why suborbital? Modern air warfare is a game of speed, altitude, and surprise. Hypersonics change the math, but what if you could combine the speed of spaceflight with the maneuverability of an aircraft? Suborbital jets operate at the thin edge between atmosphere and space. They get above most air defenses, sprint at hypersonic speeds, then dive back into the air to strike. That vertical advantage is a strategic multiplier, faster response, deeper reach, and a harder target to track. The basic concept. Think of a suborbital jet as a rocket-augmented fighter. It uses high-thrust boosters or combined cycle engines to punch through dense atmosphere into near space. Once above 50-80 kilometers, the craft can glide at extreme speeds, using altitude as a sensor and weapons advantage. After the strike, it re-enters, re-engages as a jet, and lands. This is not cheap theater. It requires advanced materials to handle heat on ascent and re-entry, specialized propulsion for both air-breathing and rocket modes, and avionics that can switch between flight regimes in milliseconds. Propulsion, the engine challenge. The heart of the idea is propulsion. Several engines are being explored. Combined cycle, turbo ramjet plus rocket, uses an air-breathing engine at low altitude, then switches to rocket mode for the climb. Scramjet, ramjet, hybrids, optimized for sustained hypersonic flight in the upper atmosphere. Boost plus glide architectures. A booster pushes the vehicle to edge of space speeds. The vehicle then glides at Mach 510. Each approach forces trade-offs. Fuel mass versus range, heat shielding versus weight, and complexity versus reliability. Achieving reusable, quick-turn suborbital sorties is the engineering mountain program managers are racing to climb. Survivability and tactics. Why would a military accept the cost? Because survivability changes. Grounded air defenses, radars, and missiles tuned for atmospheric tracks can be bypassed by a craft that arcs over them. From near space, sensors see farther. Weapons can dive from unexpected vectors. Suborbital jets could be used for rapid strategic strikes, anti-access/area denial, A2/AD suppression, or rapid force projection across continents. Tactically, they'd be game changers. Imagine a craft launched from a carrier or hidden runway, popping up briefly above 80 kilometers, delivering a precision strike, and being home before the enemy can assemble a coordinated response. The technical barriers. The barriers are real and brutal. Thermal protection for re-entry, lightweight but strong structures, guidance in the thin upper air, and engines that operate across massive temperature and pressure swings all must be solved without crippling weight. Reusable heat shields, active cooling systems, and advanced composites are required. Avionics must handle multiple flight regimes, low-speed dogfights 1 minute, hypersonic glides the next, and crew survivability becomes a serious question. Can pilots tolerate the G-loads and radiation? Will these be piloted or remotely controlled or autonomous? Each choice adds complexity and policy headaches. Who's chasing it and why now? Several nations and companies have prototyped elements, spaceplane experiments, hypersonic test beds, and dual-mode propulsion programs all point to real interest. The drivers are simple. Hypersonic missiles are becoming widespread. The only way to stay ahead is to put manned or remotely controlled capability into the high-altitude layer where response windows are measured in minutes. Military planners don't just want to strike fast. They want options that change the decision calculus for adversaries. Budget politics matter too. The overlap with space launch technology means dual-use investments. A single breakthrough could serve both space access and frontline combat. ethics, strategy, and escalation. But this power comes with risk. Weapons that can strike anywhere quickly compress decision timelines and increase the chance of miscalculation. If a craft can pop up from near space and hit hardened targets, nuclear command bunkers included, the temptation to preempt rises. There are rules of engagement, arms control, and escalation concerns that policymakers must address before these systems become commonplace. There's also the legal gray zone. Are suborbital sorties military aviation or space activities? Treaties designed for satellites might come into play. Suborbital combat jets are where aircraft design collides with rocketry and space tech. They promise unmatched speed, surprise, and reach, but they also push us into a world where the line between air war and space war erodes. This is Techrupt. Subscribe now, and we'll watch the edge of the sky together.